Hello, Algebra 2 students. We're going to be talking about quadratics, the graphs of quadratics, and today we're going to be dealing with standard form. So for your warm-up, you were supposed to graph each of these on the coordinate plane that's provided for you all. I color coordinated mine so that my red one is here, and then my orange is this one, and then the one y equals negative x squared is this graph right here. So based upon that and looking at them, we can tell that for 2x squared, it's slightly more narrow than the graph that was given. And then for 1/2 x squared, it's wider. And then for the negative x squared, it's flipped, it's upside down. So that's the words that I would use when I filled in my blanks down here. Narrow, wide, and flipped, based upon what we did when we graphed those. So check your answers with my answers and make sure that you're okay with those. Then, and at any point, if there's anything that you're not sure about or if you need to pause, go ahead and use that pause button, use the rewind button, do what you have to make sure you get everything that I'm explaining to you here. So a quadratic function is a nonlinear function that can be written in standard form as y equals ax squared plus bx plus c, where a is not equal to 0. If it was, then you would have a line instead. Every quadratic function has a U-shaped graph called a parabola. And the most basic quadratic function is y equals x squared. It's also known as the parent function. It's the one that we'll compare everything else to. It's the base function, like y equals x. So a couple things I want to point out to you all as you're looking at this. This is our parabola. It's opening up. The vertex is right here. It's going to be the lowest point if it opens up. If it was opening down like this, then your vertex would be that point, the highest point for that point. What else? The vertex for this particular one is 0, 0. And the line that is drawn here, it's this red line on your paper, that is known as the axis of symmetry. That means everything on this side is going to be symmetric to this side. So if I have a point here that's 1, 2 away, then on the opposite side, 1, 2 away, I'm going to have another point there. It's symmetric. Like you are a symmetric person. That means your left eye is approximately the same length as or the same height as your right eye, unless there's something else going on there. So that is your parabola, your basic shape of a parabola. So we're going to graph this first one, graph the function, and then compare it with that parent function that we just looked at on your other page there. For this, I'm going to do this in just 4 steps. So when it says graph and compare, this is what I want you to do. I want you to make a table, which is kind of provided for you, plot points, and draw the parabola, and then we'll compare. When we don't have a b, because remember for standard form, it's y equals ax squared plus bx plus c. So there's no just regular x term for this one. All you have to do is these steps. I'm always going to put 0 in the middle, and then I'll pick 2 numbers that are after that, like 1 and 2, and -1 and -2. Every good and acceptable parabola will have 5 points. Every parabola will have 5 points. The first one that we'll find is our vertex, which will be this one in the middle, and 0 will always be your vertex as long as there's no b for this one. So it makes your life a little bit easier for you. Just trust me on that one. So how do we get these other values? Well, you're going to plug them into the equation that's given. Ooh, that scared the heck out of me. Y equals 1/2. Instead of x, you're going to write -2 for the first one, squared minus 4. I'm showing you my work for the first one, but I probably won't do it for all of them. Minus 4, so half of 4 is 2. Minus 4 is going to give you -2. -2 for that one. Then when you plug in, I'll show -1 also just because it's a fraction, and I know some of you hate that. You could have also done these two just because whatever you get for this number will also repeat here. Thank you to the axis of symmetry. And then you're going to have half of 1 minus 4. This is 1/2 minus 4, which is -3.5. You can use your calculator if you don't believe me, but this won't be a lesson on arithmetic. And then for 0, I got -4, and because it should be repeating, this will be -3.5 also. So axis of symmetry means this will repeat here, this will repeat here. It's nice, it's a gift for us. Step 2 tells us to plot the point, so go ahead and plot your points. 0, negative 1, 2, 3, 4. And then you had 1, or I'm sorry, negative 1 and 1, 2, 3.5. I know the axis of symmetry should repeat right over here. So this is also 1 and negative 3.5. And then your last one was 2 and negative 2. Symmetric, same distance there. So draw my parabola. That's your step 3. Takes a little bit of getting used to. And then for us, we're going to label, but we won't write the whole entire equation. We'll just label your vertex, which for us is 0, negative 4. It's a very important point. The last thing that they asked us to do is to compare it. So my comparison is, in comparison to that first graph, the blue one on the back side of this paper, this is shifted down for 1. That's a D. And it's just a little bit wider. That's your comparison. Go ahead, press pause right now if you need to. Otherwise, we're going to continue here and go over some basics. So that graph was nice and user-friendly because the vertex was at 0. So you just picked a couple numbers below it and above it, like 1 and 2 and negative 1 and 2. That does not happen all the time. It's actually quite rare. So a lot of the times they'll be in standard form where you will actually have a b. Y equals ax squared plus bx plus c. So a couple things I want you to notice here. The graph of this is a parabola, and it will open up if a is positive, and it opens down if a is negative. So this greater than 0 means positive. Here's what that's saying. If a is positive, it opens up. And then if a is negative, it will open down. Negative people, what do? They frown every day, all day. Positive people, so positive A will open up like a happy face. That's what will happen every single time. That's one way to remember that. And this graph is narrower than the graph y equals ax squared if the absolute value of a is greater than 1. That means if you get any number that's bigger than 1, then it's going to be more narrow. If you get any number that's a fraction, like less than 1, then you will get something that's a little bit wider, stretched out more. And then it's going to have your axis of symmetry here, and this, if you have a highlighter, highlight it. Otherwise, do a nice little happy cloud like I just did, because it's important. You will need to memorize this formula, absolutely 100%. And it has a y-intercept of c, so 0c is also a point on the parabola. So some steps for graphing these, and you'll use these less and less the more comfortable you get with this. You can read them on your own, but we're going to use them in just one moment. So read them now as I scroll down. We're going to do this first one together. So first step that you have on your paper is to determine if it opens up or down. Well, in order to do that, I need to look at the A. And for me, my A is 1. Eventually, I'm also going to need the B, which is negative 2. And A is 1, which means it's positive. Positive people smile. So this opens up. The next thing for step 2, and this is on a separate sheet of paper, so you can look at them side by side if you wanted to. Find and draw the axis of symmetry. So the axis of symmetry was the equation x equals minus b over 2a. It's on your previous page. So plugging in, I have minus of negative 2 over 2 times 1. Negative times negative is positive 2 over 2, which is 1. So my axis of symmetry is x equals 1. They asked me to draw it, so I'm going to draw it also. Remember, when you only have an x, it's a vertical line. That's just a bell. Yeah, it just seemed like I was just cussing right there, but I wasn't. So then you have y is equal to, because in order for us to do step 3, which is to find and plot the vertex, we need a coordinate for it. So coordinates have an x part and a y part. The x part is this. We need to find the y. So I'm going to plug in 1 squared back into this equation, minus 2 times 1 plus 1. 1 squared is 1, minus 2 plus 1 gives me 0. So my vertex is at 0. Just kidding. My vertex is at 1, 0. Let's plot that. And because I know I'm going to need to label it later, I'm going to label it now, 1, 0. Now, step 4, find and plot 2 points on one side of the vertex. So an XY table is what I'm going to use, and I'm only going to use 2 points. You can use 2 points here or 2 points here. I'm going to go with this side because it has 0 on it, and 0 is the easiest number in the whole wide world to deal with. And I'll pick -1 also. I'm not going to pick ginormous numbers because it's just not good look for me. So to find out these values, again, you'll plug them in wherever you see an x. So 0 squared minus 2 times 0 plus 1 is going to be 1. So my next point is 0, 1. And then when I plugged in -1, and you can do this on your calculators, I'm going to encourage you to do that. But I got 4. So -1, 1, 2, 3, 4. And then the next thing says to reflect these points. So if this one's here, the one on the opposite side is going to be here. So 1, 2, and then 1, 2. You've reflected it without having to do any extra work. You've got those. So step 6, congratulations, you've made it. Connect your points. Try to make sure that this kind of is a little bit more rounded and not a point, because we've done our absolute value ones and those were pointed at the end. It was a V. This is a U shape, so it should be rounded at the bottom there. Love it. Yes, you do. Keep it moving here. The next one, similar to the other thing, I want you to follow the same steps. Your A is equal to 1/3 and your B is equal to 6. If you'd like to, though, you can press pause and then work this out on your own and then unpause to see my work. I wouldn't mind that. X is equal to -B, so -6 over 2 times A, except I bet you a lot of people unpause once they saw this fraction. This, by the way, is my 6. My 6 and my B look alike. I know, they're twins. -6, and then this is going to be 2 over 3. How do we get rid of that? Well, I'm going to multiply by the reciprocal to get rid of it, because actually, I'm going to show you what I'm doing. This is -6 divided by 2 over 3, which is the same as -6 times 3 over 2. So this will cancel, and so I get x is equal to -18. It's a big number. Feels wrong to me. Let's double check that. This would be 3, so 3 times 3 would actually be 9. Psych. Making sure you're paying attention. So I'm looking at -9, and I'm pretty positive it's not going to fit there. So instead, I'm going to have to go by 3's. This will be -3 instead. So 3, 6, 9. And this is my axis of symmetry. Yes, I do want you to draw this every single time. So I have my axis of symmetry. Great. Step 2 is done. Step 3 is asking me to find and plot the vertex. So x and y. Oh, I'm just kidding. X is -9, so I'm going to plug that into this equation. Y equals 1 over 3 times -9 squared plus 6 times -9 plus 3. You can use your calculators or you can trust my math. Once I do that, I get -27 for x. So my vertex is -27, comma, I'm sorry for y. Messing with you guys' heads today. My apologies. -9, -27. So it's looking like I'm also going to have to go by 3's here as well. So, and it doesn't fit. It would, however, be right about here. This is probably the only time I'm going to let you just kind of get away with this part because the numbers are so big. So that's that point. And then from here, I'm going to let you pick 2 other points. Typically, I do like the 0, so I'll probably stay over here. And then I'll probably pick either -6 or -3. Both of those are good. For -6, I get -21 when I plug in, and for 0, I get 3. So you're going to plot those points, and then you're going to reflect as well. If you'd like to, you can press pause. I'll show you my answer in just 1 second. Okay, so don't judge me, but this is my parabola. It looks a little bit shaky, but it's because I'm working on a computer screen and not a regular screen. So wrapping this part up here, the next part that they ask you to do is to tell whether the function has a minimum value or a maximum value. Then find the minimum or maximum value. So minimum values will occur if your parabola looks like this, because this would be the minimum value. It's the vertex. And A, because it's happy, it's a happy face there, A is positive. Maximum value will be like this, and it will happen when A is